I learned a very interesting fact recently, and that is that we have a president who was a mathematician, and that was James Garfield. Well, he wasn't fully a mathematician, he was like an amateur mathematician, but I still think that's really cool. And before the Civil War, he taught at a university, taught a lot of things, including math, but also history and Greek and philosophy. But during the Civil War, he was a general, and then after the Civil War, he served in Congress. And while he was in Congress, he came up with a new proof of the Pythagorean Theorem, which is I want to present that to you today because I just found it really cool that one of our presidents was interested in math to the degree that he came up with a proof of the Pythagorean Theorem. So yeah, let's take a look at that. So, as probably everyone knows, the Pythagorean Theorem is the statement a squared plus b squared equals c squared, which is just a statement about the relation between the side lengths of a triangle. Okay, so in Garfield's proof, what he did before he even touched algebra at all, before he even used algebra, he just set it up with some geometry. So first of all, he started out with just a generic right triangle. Generic right triangle, A, B, C. And then he said, okay, well, what if you duplicated the triangle and then flipped the B side so that it's stacked up upon this original A side? So like this. A, B, C. And then he said, okay, let's duplicate it and stack the duplication on top, sort of rotate it a little bit. So now you have C, B, A. And then what he did was connected these two corners right here to make a trapezoid. So just like that. And turns out that this newly created triangle in the middle right here, this is a right triangle. And the reason for that is that so the angles in a triangle add up to 180 degrees. Well, this angle right here is equal to this angle up here. And this angle right here is equal to this angle right here. And so we know that this angle and this angle add up to 90 degrees because you already have 90 degrees accounted for by this right angle right here. Therefore, these two angles must add up to be 90 degrees. And since this right here, this entire arc is basically half a circle, you have 90 degrees accounted for here, then the rest would have to be a right angle. And that adds up to 180. So we have another right triangle in the middle, which is an isosceles triangle. Because both of the side lengths are the same. It's just two C's. Okay, so how does this relate to the proof? Basically what he did now is he took a look at this trapezoid and he said, all right, there's two ways to calculate the area of this. The first way is just saying, okay, this is a trapezoid. We can just use the equation for the area of a trapezoid. So the area of a trapezoid is 1/2 times the height times the two bases added up, which is commonly notated as a plus b, which happens to work with this. But also note that the height of the trapezoid here is a plus b. So the height of this trapezoid, the area of this trapezoid is actually just 1/2 a plus b squared. Okay, so he said, all right, that's one way you can calculate the area. The other way is you can add up the area of all these inner triangles. So first of all, you want to, since these two triangles right here are the same, you pretty much just want to calculate the area of this triangle and multiply it by 2. So that is 1/2 base times height. So 1/2 a times b. And then, since there's two of them, you just multiply that whole quantity by 2. All right, Now what about this middle triangle? It's a bit easier. It's just, again, 1/2 base times height. Well, the base is c and the height is c, so 1/2 c times c, which is c squared. Okay, so now you have the area represented in two different ways. Sorry, that kind of went off the page there. So area is represented in two different ways. So now you can say 1/2 a plus b squared equals 2 times 1/2 ab plus 1/2 c squared. And then you kind of just manipulate it algebraically. So starting off, you want to distribute this a plus b times a plus b. That is, keep the 1/2 out here. It's going to be 1/2 a squared plus 2ab plus b squared. And then you got this equivalent to, let's go ahead and get rid of the 2 times 1/2 right there. This is equal to ab plus 1/2 c squared. And now what you can do is just multiply everything by 2. So what you have next is a squared plus 2ab plus b squared equals 2ab plus c squared. And the last step is subtract 2ab from both sides. A squared plus b squared equals c squared. And that's his proof. And that was the president who did that. So thanks for watching. I read about all of the proof on the Mathematical Association of America website, so I'll leave a link to that in the description. But yeah, thanks for watching.